So hello, my name's Choroba, and I'm going to show you some of bizarre programming practices and mistakes I encountered at one of my previous jobs. Nowadays I work for a company called Good Data in the Czech Republic, and we are hiring. And on the last slide you'll see an URL of the slides, and you'll be able to click all these things to get more information. Okay, so I'll start with some disclaimers. So the first one, all variable names have been changed. In fact, I haven't copied any code from the code base. Everything was written from memory and from scratch, because the code is probably copyrighted and it would be illegal to show you the original code. But I tried to keep the spirit of the code. The second point, I'm not trying to ridicule anyone. Okay, so the company I worked for was a well-known, very large financial institution. You probably know the company. I'm not going to tell you the name. And the people working there were probably not good programmers, but they understood the business well. Some of them were very helpful and friendly. So it's not about making fun of people, but rather showing you what's possible and sometimes go deeper into the problems to show how you can solve them or whatever. We'll see. The company was very large, so there were many other projects and teams. So I'll only show you what happened in our team, which was rather small. So it's quite possible that there are other products by the company that are much better. So the point of this is to learn from the mistakes and to give you some optimism, so you can think, well, our code base isn't that bad, or at least I'm not alone. So I'll start right with the first example that probably shows that the people originally in the team were not programmers. So there was a part of, I don't want to say subroutine because they didn't use subroutines much, but there was a part of the code which looked like this. So at the beginning, we check some permissions of a user in two different ways, because the code depends on the way how it was called. It could be an HTTP post or through a web page, and the default values were different for each call. And then we check some application parameters. These are basically CGI parameters. And you can see that there is order signed by perm_r. And then we have this repeated, and I can scroll down. And it gets repeated for user 4, user 5, 6, 7, 8, 9, 10. And that was the limit. There were 10 fields in the form to fill in. So at the maximum you can have 10 users permission for an action. And that was one of the first things I refactored. I used an array, and the product manager was kind of scared that something might break. So I imagined how a hiring process might look like. So you get the question, what will you use if you want to represent 10 values of the same type in a sequence? Well, 10 variables with similar names. Great. Hired. So, yeah, this was the beginning. Okay, another funny thing was boilerplate code. There were not many subroutines, but when there was a subroutine, it usually started with something like this. Probably in case you needed a variable later but couldn't declare one. What was interesting was the fact that not all the variables were used during the code. And if a variable was used from the first line, it was usually I, sometimes J, then M, N. So you never knew. Similarly, the results were sometimes populated, sometimes not. Sometimes returned, sometimes not. Okay, and now for something really interesting. The code didn't use strict, no warnings, and it contained quite interesting stuff like the following one. So this generates a list in HTML, but for some of the elements, you can highlight them somehow if they are selected. And you can see that we have a hash called list, which is keyed by the ID. And for each ID, we have a hash reference which says selected, and it could which has a single key selected, which might be set to 1 if the thing is selected. But at the same time, on the last line, we print list key. And it doesn't print hash and some number. It really prints the text that we wanted to see. So how does this work? Has anyone ever seen this? Like it's a hash reference and a string at the same time. How is that possible? If you are familiar with Perl without strict, it should be something you know. It's symbolic reference. They didn't know. They told me it just works. We try to debug it and it's magical. We don't know. So I tried to debug it, and it's, in fact, the list key contains the name, that the text that is displayed in the list is interpreted by Perl as a symbolic reference, which means a variable name that has a hash reference which might be set to 1 if you want to select this thing. It's very dangerous because the variable is global. So if you have two lists that share this behavior, you can have things selected in one list that should be selected in the first list. Okay, so I wanted to fix this, but at the same time, just for curiosity, I wanted to see whether this is possible in Perl under strict. And interestingly, it's possible with pure Perl. Anyone has a tip what to use to have a variable that behaves as a string and a hash reference at the same time? Overloading? Overloading is almost the thing, and tying is the other thing. So here's the code. So basically we overload stringification, and we store the value in a special string, under a special string key in a hash reference, hoping that there will not be, in the list, there will not be a string item. And because we use the key directly on the cell, we could probably store the hash somewhere else to make it 100% safe, but it doesn't matter. And when storing the value, we store the string under the key, and that's it. And it works, if you run the previous code under strict, it behaves exactly as it behaved before, with the exception that the value is now not global. Okay. Another interesting feature of this project was that it didn't use packages. So the whole code was just many PL files, scripts, requiring each other. You can see that there were two ways how to include a script into a script. And using these two ways was in fact needed because with require, Perl remembers whether the script was already required and it doesn't load it for the second time or pass it for the second time. But there was one file that was a PM file and actually used a package. It was an object-oriented package. And it needed some of the functions to be included into its namespace. But if you use require with the same path, Perl knows that this has already been required, so it wouldn't add the functions to your namespace. So you have to require something else, because Perl just remembers in the INC hash, you'll see this whole string as the key. So if the parameter to require is a different string, both of them go to the INC hash, and you can require the file for the second time and get all the symbols imported to your namespace as well. I'll show an example. Okay. So there is a script, common PL, that will be needed in both the application PL and namespace PM. It gets a common date from a database. I try to keep the naming similar to what they used in the project. And you can see that in the application you require the common script and then just call the common get value for date using the ampersand notation. And in the namespace package, NS, we require the same script under a different string. So the common get value for date can be called like that. Otherwise, we would have to say main common get value for date. All variables are global, yeah. And there were like, the code had more than 100,000 lines. Okay. So one of my first tasks was to fix a code flow in an upload script. And there were, as we have already seen, there were 3 entry points to the upload script. One of them was, you could call it from the command line with parameters. You could call an HTTP post to kind of API, or there was a web page where you can fill various things in a form and then submit that form. And the code was kind of complicated, so they wanted me to unify the flow for all three entry points. The problem was that there were three main parts of the process, and they were called in different order for each entry point. So this is just saying that for command line interface, you call F0 first, then F1, then F2. For the HTTP post, the order is different, and for the web page, the order is different again. Maybe a picture is better. And basically, every time when we branch, we have to check how we got there. So we start with, for example, for command line interface, we start with F0. Then we have to check whether we were called through HTTP, because if not, we have to do F1, otherwise we go to F2, and so on and so on. So this was pretty hard. And in fact, I wrote a tracking code that reported various parts in the code in a format that I can feed it to a dot program, and I got this picture much more complex that really showed how the code behaves, and then I was able to fix it somehow. I think there are still two ways, not three. I wasn't able to get it to one. Okay, another interesting thing, and at the same time a thing to keep in mind. So the application was running in in a 32-bit version of Perl 583, which was 10 years old at that time. And the Perl 583 was, the binary was copied from the original machine that didn't exist at that time. And unfortunately, they didn't copy the GCC used to compile that binary. So it was not possible to add any excess libraries, only pure Perl. And we had to migrate to Red Hat 6, which was on a 64-bit machines. And they just copied everything again. And it seemed to run, but the transliteration operator stopped working. We had just this for squashing white space. And it didn't work for large strings. If the string was UTF-8 and longer than 32,768 bytes, it just inserted garbage in the middle of the string. And they discovered that using the substitution instead works, even if it's a bit smaller. So they switched to substitution. But I was quite curious why that happened. And the only thing I was able to find was that the number corresponds to the size of the read buffer. So it might be somehow related to something like that somewhere in C below. I didn't get to a real explanation of what went wrong, but I think that if you copy a binary several times to a different architecture, all bets are off. Everything can happen, or anything can happen. Okay. Yeah, switching from FTP to SFTP. So we used FTP to send some files to another well-known company. And one day they informed us that they would cancel their FTP support, and we had to switch to SFTP for security reasons. Without GCC, this wasn't possible, because for SFTP, you need somehow, well, it's possible if you allow passwordless access with a key, and the key has no passphrase. Then it's possible to use pure Perl. But that was not possible because the client insisted on either having a password or a passphrase. So for having a password or passphrase, you need sudo terminal to enter the password or passphrase. So you need something to compile against the library. So there was no way how to achieve the goal. So in the end, I was able to install Perl 522, or what was the current one at that time, and switch this part of the project to the newest Perl, where compiling net SFTP foreign was easy, and just adding several things to the shared libraries so they worked both in the old and new Perl. Okay, and there was a config file for the FTP transfer, and it used to specify, among other things, that the port is 21, which is what is normally used for FTP. But it was ignored by the code. It used the default for the library. So when I changed it to use net SFTP foreign, I also added support for this option and added port 22 to the config. Then I was told to remove the code that handled the port, because that was not the point of the change. We just wanted to switch to SFTP. We didn't want to add new functionality. So I removed the code that handled this config option, and I also removed the port 22 from the config. But they told me to keep the port 22 in the config for readability. And you can imagine what happens one day when they want to switch to a different port and they change it in the config file, but it doesn't work. Okay. Another debugging nightmare. When I switched the system to SFTP, I wanted to verify something, so I added some logging to the code. I'll try to make it. Okay, now we have the whole code on the screen. So you can see at the beginning, something goes to the log, and at the very bottom, something else goes to the log. And the problem was that the first message got to the log, but the second one was not there. And I used syntax highlighting in my Emacs, and you can clearly see that there's just changing variable values, nothing else.
But you changed the log file.
Exactly. Yeah, that was the thing. But in fact, this part of the code was much, much longer. And in the end, yeah, it was the line that has the 3 exclamation marks in the end. They changed the log file in the middle of the code. So the rest of the log was in a different file. And took me several days to discover that. No, global variables, great. Okay, now another nice debugging session with caching a database. So there was a large table in the database, and as an optimization, the code fetched the table just once and cached it for later use. But the behavior with the fresh table was different from the behavior with the cache, and we weren't sure why, or I wasn't sure why. And yeah, when I removed the cache, it behaved well. So again, I spent several hours or maybe days debugging the code. And in the end, I found that the cache was in fact just an array of strings represented in this way. And guess what happened to nulls? They were translated to empty strings, but the code depended on defined, undefined values having different meanings. So
More problematic is if value 1 contains a 5.
I don't know. Yeah. Sorry?
It proves that the developers knew arrays.
Yeah. Okay. Another nice thing happened to me when I added some subroutine to a code, and it used date manip. So I added use date manip at the top of the script, and they told me, no, don't add this line, because this script is only used in context where date manip is already used, so it's useless to use it again. Which is very clever, especially when you later need to use this script in a context where date manip is not used. Okay, dates and times. So this will be a bit longer and maybe more educational than the things before. So this was a long story, and it involved more departments. So there were two systems, and for, let's say, order, there was some kind of maximal validity period. And after 1 year, the order was no longer valid. But the two systems, our system and one system of the other department, implemented the logic in a slightly different way. So the system one, let's say that was our system, it took today and then incremented the year by 1. The other system took today and added 365 days. Seems okay? Almost. Well, on 1 day. Okay, so we have daylight saving times. And I will try to show you what happened. So on the 8th of March, DST started, which means in the table below you can see that if we have February the 28th, it in the year 2016 corresponds to February the 28th, and the difference is 365 days. The problem is that the February in 2016 has 29 days. So for March the 1st, we have 366 days. So on the 1st of March, suddenly the orders were rejected because their invalidation date was illegal in one of the systems. My solution was easy. They just added 1 day. So they, instead of 365, they used 366. So it broke the next week because of the ST, because the difference was now 366 days and 1 hour. So they fixed that by adding 1 day again. So nowadays the system just adds 367 days and they hope it will work forever. And it was very hard to explain the second failure to the management. Okay, time zone names. As you can read in many blog posts and in the documentation for various data handling modules, you shouldn't use the short names for time zones like EST, because some of them are ambiguous. And you might think that, well, something is ambiguous, but why does it matter? So we had a production incident that showed that it matters. The firm is a global one with business in almost any time zone. So for example, this date makes no sense in New York because EST is not in, how to say it, New York doesn't observe EST at that time. Yeah, there's daylight. So there's EDT. But the time, or this 2015 March 9700 EST is a valid timestamp because in Australia, Queensland follows EST for the whole year. So this is a normal timestamp, but in Australia. So it suddenly transfers you to a totally different continent, which also meant that some script ran in a totally wrong time. Yeah, instead of running at 7 in the morning, it ran at 5 in the evening. So, here is just a short bash script that shows you how to do the calculation and to see how the timestamps are related. Okay. Next business day. So this was another thing related to dates and times. So we used date manip. In order to simulate the behavior, I had to set the backend to DM5 because date manip is now on version 6, if not higher. But under the old behavior, this problem is still replicable. So there was a subroutine with some kind of a comment at the beginning, and it somehow looked like it should return the next business day, but there was some really complex computation going on. And on the old architecture, on the 32 bits, it worked well. But when we moved it to the 64-bit architecture, it started to time out. And when I switched the timeout off, it returned after 7 minutes with an exception. Invalid year, 10,000. add blah 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 date manip something. So this was also very hard to debug, and the problem is that when you do the, where is it? In date manip, when you search for the next business day, you can tell it how many days it should look forward. Like, show me the next business day in 20 days. And what it does, it counts the business days. There's no easy way how to do all the holidays and stuff. So it goes day by day and decreases the day count. And when it comes to 0, it says, this is the date. The problem was that when we switched to a different architecture, in fact, there was an error in the code. You can probably still see it if we had more time. One of the values that should be really small instead returned the internal representation of the date as a number. So it was 20150314, something like that, very large number, which on the 32-bit architecture turned into negative number. So the loop ended at the first iteration because it was below 0. So it returned the same day every time, the today. But on 64-bit, this looped and looped and looped because it was not negative, and it was decreasing the large number until it came to the year 10,000, where the library says, I'm not going any further. And that was really exceptionally hard to debug, because this only happens under use integer. And use integer doesn't propagate to the debugger context. So when you debug the code and you do the examine this variable, you see a totally different value to what the code sees. Interesting. By the way, time zones. So we didn't use cron. Cron is for hackers. We used autosys. Autosys is much better because it has a web interface and managers can plan tasks. And they can rerun tasks, and they can see what tasks were run and what the output of the tasks was and stuff like that. But autosys is a bit more complex than cron. It has a server where you can store the tasks, but it can run them on different computers on your internet. And for each task, you can specify at what time the tasks should be run. The problem is that the version of autosys we had used the local time for specifying the action. So you had to know where the server was located. We had some servers in Singapore, some in New York, some in London. And we used different servers for different tasks. But you had to specify different times based on the location of the server. So very, very interesting outcome of this as well. And as I'm talking about things that they replaced by something else, so we used autosys instead of cron. Also, we used Power Broker instead of SSH. Power Broker is a software. You can find it on the web. It's very expensive. And what it does, it monitors everything you do on production. If you connect to production, not only monitors what you do, but it also can you can tell the system what different users can run. So, for example, we are able to run find on production, but when I tried to run find mtime -1, like files changed in the last day, I got Power Broker error option -m not allowed for command find, because as I later discovered, it was written in Python, and it parsed the options by hand somehow, and it didn't have support for options longer than one character. Okay, and another thing they used, what's the time? Oh, we're running out of time. So absence. We were developing for Linux machines, but our developer machines were Microsoft Windows, because the firm only can provide Microsoft Windows machines to their employees. And they didn't want us to have admin rights, because it was a security issue to give admin rights to people. And at the beginning, when I joined the company, the developers were given admin rights because we needed to set environment variables to compile Java code or something. But they decided they'll buy another very expensive product called Absence, which somehow intercepts every call to a new, every execution of code on Microsoft Windows, and decides what rights to assign to this new code. So running proof slowed down from 20 seconds to 2 minutes, because if you run proof, it runs many forks of Perl, and Perl was not whitelisted, so it was checked every time. So I asked whether it could be possible to add some things to the whitelist, and in the end, I discussed this with the developers of the tool, and they had a whitelist which was stored in the Windows registry, and there were just the names of the binaries without path, just the names. And some things were listed there. So, for example, bash.exe was listed there. So if you named your application bash.exe, you were safe, you were whitelisted. And the problem was that they wanted me to send them the list of files I want to whitelist. So I just copied my /user/bin in Cygwin and sent that to them, and they told me, well, we can't do that because Windows registers have limited length, and that was too long. Okay, so we are almost finished. Testing. So I was implementing a feature that was quite complex, so there were no tests. There was not a single test. So I wrote I called it a black box test that just run the application, and then it just checked that the outcome is what we expected it to be. And I was told that I was wasting my time writing tests no one wanted me to write, instead of delivering the feature whose deadline was coming in 3 days. And one day before the deadline, the specification changed. And fortunately, I had a test, so for me it was easy to change the code and to verify that everything is okay. So the change was done in 10 minutes, maybe 15 minutes. And without the test, it probably wouldn't be possible to deliver the change at all. So if this sounds scary or familiar, my advice is try to change as much as you can. I had a very supportive manager, so in the end, many things were fixed or at least moved to a better state. And in the end, you can always find a better job, which I did in the end. So, thank you.